Hey guys, so we're going to move on to the next lesson in chapter 3. It's lesson 3.2. We're going to start talking about imaginary numbers, imaginary unit, complex numbers. So let me present my screen and we'll get started. Okay, so we're going to be talking about the imaginary unit. It says here definition, the square root of -1 denoted by I. I is equal to -1. Okay, so up until this point, anytime we were trying to take the square root of a number, if the number we were trying to take the square root of was a negative, we'd always say, oh, can't do it, no real number, no real solution. Okay, so now we are going to be able to continue to work through problems where there's a negative under the square root, because now we know that -1 is equal to I. All right. Complex numbers, a number written in the form of a plus bi, where a and b are real numbers. Okay, and notice that the imaginary part comes second, the real part comes first, and that's important. All right. Imaginary numbers, a number written in the form a plus bi, where a and b are real numbers and b cannot equal 0. All right, so we have 10 minus 2i. Again, it's the real part followed by the imaginary part. And then pure imaginary numbers, a number written in the form a plus bi, where a equals 0 and b does not equal 0. So that's meaning that a, the real part, is not going to be there. We will only have the imaginary part. So an example would be 5i. Right? So before we move on, or actually I guess I can write it down here when we talk about the square root of numbers. All right, so the square root of a negative number, we have some properties. It says if r is a positive real number, then the square root of -r, again, when we see that negative underneath of the radical, it's going to look like you're kind of pulling an I out. You're indicating that it is a imaginary number. So it's I square root negative, or excuse me, I square root r. So for example, the square root of -3 is equal to I root 3. Okay, and the reason that is, again, just to kind of explain a little further, you can rewrite the square root of -3. You can rewrite that as the square root of -1 times the square root of 3. And since we discussed up above in the vocabulary, that the square root of -1 is I, so it's I root 3 is what you're left with. Okay, so again, it's important to know that I is equal to the square root of -1. Or if I square I, so I squared, right? If I square I, I'd square the other side here. I squared is equal to -1. So this is going to be an important fact to take note of throughout this lesson. It says, by the first property, it follows that I root r squared is equal to -r. So for example, I times root 3 squared, so you're going to square the I, that's where the I square comes from, and square the root 3. Well, the square root and the square cancel, so you're just left with 3. And then since I squared is equal to -1, remember I wrote that up here, you have -1 times 3, which is how they come up with just -3. All right, we'll do more examples of all those below. Just let me scroll down. One more thing before we jump into the problems. We have, pen out. We have sum and differences of complex numbers. To add or subtract two complex numbers, add or subtract the real parts and their imaginary parts. All right, so when you're adding or subtracting these complex numbers, you're going to find like terms, okay? A is the real part, C is the real part, so you're going to add them together. And then BI is the imaginary part because it has the I. DI is the imaginary part, so you're going to add those together, and you add their coefficients, okay? And same thing is true. Just make sure you distribute the negative into the parentheses if there is a minus sign before you drop the parentheses. All right, let's keep on moving down. Okay, so now let's work through some examples. First, we have, we want to find the square root of these numbers. Again, up until now, we'd say, oh, can't do it. There is no number squared that's going to equal -49. But now I know I can rewrite this as the square root of Oh, let me start that over because that's messy. Try again. Okay. So I can rewrite this as the square root of -1 times the square root of 49, right? I'm just rewriting square root of -49 a different way. Now I know from today's lesson that the square root of -1 is I, right? And then I know that root 49 is 7. And then I multiply together to get 7i. For the next one, same setup. Square root of 45 can be rewritten as square root of -1 times square root of 45. So this is I times, and then instead of 45, you could break that into 9 times 5. And then the square root of 9 is 3. So I have I times 3 times root 5. And root 5. And then I rewrite that. My final answer is 3i root 5. Okay. Let's keep on going. Okay. So for the next example, same kind of setup as what I was doing above. I'm going to break it apart. Root 2 times square root of -1 times square root of 100. All right. -2 times I times 10. You're going to multiply the -2 and the 10 together to get -20i. Okay. And the next one, again, break it up. 5 times square root of -1 times square root of 75. So I have 5 times I, and then the square root of 75, I'm going to break it into the square root of 25 times the square root of 3, because 25 times 3 equals 75. And I have 5 times the square root of 25 is 5 times root 3. Multiply the 5's together to get 25i root 3. Okay. Erase and move on down. Next, you're going to be asked to find the values of x and y that satisfy the equation. Okay, so there's basically steps to follow here, and I'm going to write the steps down in the middle, and then we'll go through the problem. The first step is to identify the real parts and imaginary parts. So identify real parts and imaginary parts. So when I say identify, maybe we'll just underline. Anything that has an I is an imaginary. Anything that doesn't have an I is going to be your real. So I'll circle my real, I'll underline my imaginary. Okay. Step 2 is you're going to set real parts equal, and then you're going to set imaginary parts equal. And then finally, solve each equation. All right, so if I take my real, the ones without the i's, I have -10x equals 30. And if I take my imaginary, I have I equals -yi. So now I have equations where I can solve for the variables. I'm going to divide both sides by -10. So I have x is equal to -3. I have to solve for the other variable y. So I'm going to divide by I to start. I divided by I, just like 5 divided by 5, 2 divided by 2. When numerator and denominator match, it's just a 1 equals -y. And then divide both sides by a negative. Then you have y is equal to -1. Okay. Let me erase all that so that we can do the next problem. Same setup. So you're going to identify the reals and the imaginaries. This is real. 44 is real. and negative 1/4 x is real. And then this is imaginary and this is imaginary. So the reals are 44 equals negative 1/4 x. Get rid of that. Try that again. 1/4 x. And then the imaginary is negative 1/2 yi equals negative 7i. All right, so I'm going to multiply both sides by the reciprocal, so it's a negative 4. Multiply this side by the reciprocal, negative 4. So the fraction cancels with the negative 4 over there, and you're left with negative 176 equals x. Now, the easiest thing to do here is first just divide both sides by an I. I see that they both have an I, so if I divide by I, the i's are eliminated. So I have negative 1/2 y equals negative 7. I'm going to multiply both sides by the reciprocal, which is negative 2. So negative 2 times negative 1/2 is a positive 1. So you have 1y equals 14. All right, let's keep on moving. Okay, the next section says simplify the expression and classify the result as real or imaginary. If the result is imaginary, specify if it's a pure imaginary number. So simplifying meaning combining like terms. Before you can drop parentheses here, you do need to distribute the negative. Okay, so distribute the negative and then you can drop the parentheses. 36 minus 3i minus 12 minus 24i. So combining like terms, start with the reals first. 36 minus the 12 is going to leave you with 24. Then you're going to look for your imaginaries, negative 3i minus 24i. All right, and that's going to give you negative 27i. Right, and this is imaginary because there's an I involved. It's not pure imaginary, it's just imaginary. The next one is a plus sign in between, so I can just drop parentheses. Combining like terms, starting with the reals, 16 minus 16, so that's eliminated. I minus 8i is a negative 7i. This is imaginary, but it's a pure imaginary. It's pure imaginary because there's no real part. There's only the imaginary part. And finally here, we're distributing. Notice there's no plus or minus in between, so that means I have to FOIL. First, outer, inner, last. So 13 times 13 is 169. Then I'll have minus 13i. Then I'll have plus 13i. Then I'll have negative I squared. The middle terms cancel because one's negative, one's positive. So I have 169 minus I squared. But you're not done. I squared is equal to negative 1. So I can substitute. In place of the I squared, I put a negative 1. 169 minus a negative 1 is 170. This is a real number because there's no imaginary component. All right. Let's keep on going. Solve the equation, check your answers. Okay, so isolate the variable, just like we normally would solve an equation, isolate the variable. So I'm going to subtract 25 from both sides. So I have negative 25 equals 5x squared. I'm going to divide both sides by 5. So I have negative 5 equals x squared. Then I'm going to take the square root of both sides. Don't forget to do your plus minus. So you have plus minus the square root of negative 5 equals x. And then finally, because of the negative, it's x is equal to plus minus I root 5. Remember how we simplified above? You can rewrite negative root 5 as negative root 1 times negative 5, and then the root 1 is an I. Okay. Here I'm going to add 10 to both sides. So I have x squared is equal to negative 8. I'm going to take the square root of both sides. Don't forget plus minus. So plus minus the square root of -8. And I'm going to simplify that first to just I root 8. And then 8 has a perfect square factor of 2. Okay, so I'm going to simplify that, or sorry, a perfect square factor of 4. It simplifies down to a 2. So it's 2I root 2. All right, and for this last one, I'm actually going to multiply through by the LCD of 15 to eliminate my fractions. So when I multiply through by 15 over 1, I'm going to cross simplify here. 3 goes into 3 once, 3 goes into 15 5 times, so it's going to be a negative 5x squared. 5 goes into 5 once, 5 goes into 15 3 times, so distribute the 3. That's going to be equals 3. Plus 3 goes into 3 once, 3 goes into 15 5 times, so 5 times 4 is 20x squared. If you're not good with multiplying through by the LCD, you don't have to, right? But if you're comfortable with it, it does make the math easier. So now I'm going to subtract 20x from both sides, 20x squared from both sides. So I have negative 25x squared equals 3. Divide both sides by a negative 25, so x squared equals negative 3 over 25. Now you're going to do the square root of both sides, so x is equal to plus minus the square root of negative 3 over 25. I have to bring this up here because I'm running out of room. Oop. All right, so then I have x is equal to plus minus I square root of 3 over 25. I can break that up into plus minus I root 3 over root 25. And the reason I do that is because I can't leave a fraction under the radical. And the denominator can now be simplified. So it's x equals plus minus I root 3 over 5. Okay, that one's a longer problem. And the last problem. The last problem says sketch. Oh, I got to bring this up higher, sorry. Okay. It says sketch a graph of a function that has 2 real zeros at -2 and 2. Then sketch a graph on the same grid of a function that has 2 imaginary zeros of -2i and 2i. Explain the difference in the graphs of the functions. Okay, so let me first just darken my y and my x-axis. All right, and then from there, if I had 2 real zeros at -2 and 2, that means my factors would be x plus 2, x minus 2, right? Because if I set both of those equal to 0, I get answers of -2 and +2. So that function can be written as f of x equals, if I FOIL this all together, I'd have x squared minus 4, okay? If I have 2 zeros that are not real, let's say I had x squared plus 4 as the function. If I set that equal to 0, I have x squared equals -4. That would be x is equal to plus minus the square root of -4, which would give you your 2 answers of 2i. Okay, this function, if I was to graph it, would have an x-intercept at -2 and at +2. All right, and I'm not going to sketch the vertex because I'm just going to kind of quickly sketch it there. Whereas the other graph would slide up 4 units, 1, 2, 3, 4. 1 second.
Happy birthday.
Oh, thank you. Sorry. Thank you. Slide up 4 units, and parabola would be up here, so you can see it doesn't cross the x-axis. Okay. Sorry about that. Mr. Williams was just wishing me a happy birthday. All right, guys, so that is it for that lesson. Let me go back to my Google Meet. That is it for that lesson, and I'll see you back here for the next one. Bye.